Hello, a very good evening to everybody. Welcome to eConstructs online session. In this particular session, we are going to learn certain things, the further things about the foundation system, the foundation engineering and all. Alright, so before making it late, let's get started. This is one of the project which I wanted to show you because yesterday we have discussed certain things about how basically you are going to start the project. Alright, so for starting the project, basically you will be exporting the files from the etabs to save. By considering the maybe first option, the second option, the third option, we have seen all the three options during the last session. I just wanted to show you with this particular project is there might be the combination of varied variety of different types of foundation systems will be there. Whether it is isolated footing, whether it is combined footing, whether it is a raft, whether it is these are piles or pile plus raft. So this is basically not even pile plus raft. This is basically the short piles plus raft, and you are having the pedestals, the raft plus pedestal. So I just wanted to show you how it is. So if you just go here and see the extrusion here. So this is the extrusion here of this. Right. So you can see that the thickness of the raft is there and a little bit more thickness of the drop panels are there. So if you right click it here, you will see that the raft thickness is 800 mm, and you will see that over here the raft thickness is 2 meters. Okay, meaning to tell you that the foundation would be something like this. I'll just put this over here just to give me a moment. So what will happen like this is you are having the raft foundation in this sense. So let's say for example like this the raft is there. Understood? So the reinforcement of this also would be little different. It would be, the top rebar is definitely required here, bottom rebar is definitely required here. So sometimes it is like this, sometimes it is, if the distance between the two is very high, it will be like this, and bottom rebar will be straight. Sometimes you require the extra bottom rebar, here also you require extra bottom rebar. Here you will have the reinforcement something like this. Here also you will have the reinforcement something like this. And of course you will have the rebar in the other directions, whether that is top or bottom. Here also, side face reinforcement, you will have top rebar, you will have bottom rebar. So during the exams also, for example, if you are having a little bit more time, draw it neatly. If you do not have more time, actually you can just scribble the sketch and just inform that this is what you know. Understood? So the column is coming, this is the column rebar also will be coming and will stand here, something like this. Understood? So I'm not saying this is the best sketch that you can have. I'm just saying that you will be having something like this at let's say at this place. You are having the piles also. Piles means the pile foundation or the reinforcement will come like this. So these are the pile foundations. The pile foundations would be sometimes it will be below the pedestals also. We'll have something like this. So I'll give you the sketches, detailed sketches actually how this can be done. But this is basically the combination of a raft is there. So you can see that there is a area springs. You can see that there are point springs. Okay, you can see that there are columns. There is a slab or the foundation pad is there. As well as you can see that there are the pedestals. Raft pedestal also is there. Understood. So this is how actually a little complex way of going through the different types of foundation system. All right. So that you will be having. So during the last session, we have seen that the variety and the combinations also you will be having. We will see some more sketches today, the site photographs and all, so that you will get basically how it will be, there on the site and all. Actually, you will get a little bit more fair idea about it. So one photograph I wanted to just show you. This is the photograph. What is this? This is basically the raft. Some of you might be surprised that, oh my god, this is a raft. Yes, these guys actually which you are seeing are working inside the raft. The raft thickness is in the range of 3 meters. Got it? This is the top rebar which you are seeing it here, and this is the bottom rebar which you are seeing it here. Bottom rebar is more than the top rebar. Obviously, why? Because such a big shear walls and columns. This is 53-story building foundation, and this is actually designed by the construct. Alright, so this is basically the foundation system. This is, you can see that the foundation is there over here, and you can see that the columns and the shear walls are coming over here. Alright, so what are these Z type? What is this? This is basically to make sure that the spacing between this rebar and the bottom rebar is maintained properly as 3 meters, whatever the thickness that is specified. Understood? Yeah. So sometimes you require the I section also over here. I section also here. Why? Because this tiny little rebar is not enough. Because this bar is also will buckle because of the heavy weight of this. People will be standing, they will be concreting, and automatically the buckling will happen. It might happen. Very sure. Possibility is very high. Understood? So in this kind of context, I just wanted to tell you very surely that you need to design this also. Or sometimes here also you require to give the bracing, because it should not buckle anyway. The bracing in this direction, bracing in the other direction, because that is also a column, right? Steel column, rebar column, but a column. Why? Because it is taking the compression force. Understood? So how to design the foundation system is what we are talking about, and how the work is happening. Alright? Okay, so massive works only will be done. So you can see that the rebars is there, and this is basically, we call it as spacer bars or chair. Such kind of words are getting utilized in industry, so that you will see that this is basically, the purpose of this is to maintain the spacing between the two rebars. So this is the raft. Now let's go to the next one. What is this? You can see that these people are laying the bottom rebar, the second layer. The first layer is already laid, the second layer is getting laid. Okay, and simultaneously you can see that the people are starting the top rebar also. Understood? And what is this over here? This is the shear. This is basically the retaining wall. Retaining wall here, pedestal here, column here. Understood? So this is the bottom rebar, this is the top rebar. Yes. Okay, so let's go to the next one. So I'll give you certain live examples today, so that you'll get certain. So what is this? This is basically the neighboring plot picture actually, before just doing the execution and all. So neighboring buildings are there, and you can see that. Now let's go to the next picture. What is this? This is basically the waterproofing. Membrane waterproofing. So what are the different types of waterproofing systems are there? Why to use these? Why not to use these? What is the cost involved? What is the timeline involved? What are the labors involved? What is basically the costing part? What are the technicalities, the specifications, the thickness, the material, the company, the vendors? All this. Understood? So whenever you are dealing with any particular one subject, start going deep dive inside. Understood? Why the hell waterproofing is required here? Because during the monsoon everything will be underwater. If the foundation is laid actually and the reinforcement is there, it will start corroding. Okay, so waterproofing is also important. Got it? Now the next one. What is this? This is the PCC. They are trying to lay it here. PCC part. Plain cement concrete. What is this? Retaining wall. Retaining wall, they are marking something here. Can you see that? There is a marking here. Oops, sorry. There is a marking here. There is a marking here. There is a marking here. What is this marking? We'll look into that. Understood? But these are very, very important site photographs which you will take it. Now this is basically the foundation load testing. You know that there is a testing which you might have heard about it, which we call it as the SPT. Standard penetration test. There will be a small plate, the iron plate, the steel plate actually people will be using. There will be some amount of load and the settlement will happen. But apart from this, I would suggest, because this is a little bit older technology, apart from this, we have to use this, which we call it as the foundation testing. What is this actually? Is the actual real sense of the foundation is getting utilized, going to get utilized on the site, and here you will see the instruments. Different types of instruments will be there here. These are basically the gauges that how much is the actually the settlement is happening on the site. So instead of using the SPT, we would generally insist to use the foundation testing load. Okay. So what you need to do is you cast this same foundation which is given in the the drawings. You put some pneumatic force on the top of this, calibrate with this with the certain indigenous people who are expert into that category, and take the initial reading and apply the load and load versus settlement. Load versus settlement, where point number 1, second point, third point, fourth point. Take the average, matter is over. Understood? So that actually is known as the foundation settlements area. So this is extremely important for the high-rise buildings and all. I would suggest that you should be giving this kind of approach to the project. It is preferred. Now, what is this? See, this is PCC. Here they are starting the. This is also PCC. Here this is basically for the temporary shuttering and all. For what? For the retaining wall to go. I'll just zoom in for you. Now what the hell is this? These are shoring piles. Shoring piles. And what is this? This is the steel beam. And this, what is this? This is the PT strand. PT strand. Why the PT strand is given? So that the pile should not come out. Pile should not come out. Understood? Yeah. So these are, and why the shuttering is given? Because you are required to get this casted. So there is a sequence. And then what is this? This is basically the shoring beam. This beam, see, certain piles will start coming out, certain piles will go there, certain piles will come more here, less here. So you require one line. Follow this rule. Yardstick. So who will do that? This beam. This will be done on the top. Bottom side also there is an anchor of the soil. In between, if it is having tummy, the buckling effect, what will happen? For that only this beam is given. Understood? You don't want this to be cantilever. That's why this particular post-tension strands are given. Understood? So these are certain site photographs. Okay, I would give you one small exercise. Please note down everybody that the deep foundations, You have to watch minimum 20 to 30 videos on the YouTube. If you go to any channel, doesn't matter. Watch the videos, download it, show me what you have watched and what you have understood. Okay, we'll have some this kind of sessions also over the period of time. Foundation system, what are the precautionary measures and what kind of materials that you will be using, where you will be using, what kind of instrumentation you require to use, what kind of pump you need to use, the drainage system, how are you going to use. Understood? And along with that, you need to test also the foundation load test, or maybe the tension inside this kind of PT strands, how much tension it is coming, and this how much tension it is coming, and how much you have considered during the analysis. Okay, so some of you might be thinking, oh my god, kidhar phas gaye. That's why I told you, if you remember before starting the SAFE series of workshop, that this is going to be, if I am saying that out of all the workshop, the SAFE is one of the toughest one, it is because of that only, because you have to deal with the many vendors, PT vendor, the shoring piles vendor, RCC vendor, then you do the PCC soil testing, then there is a waterproofing, oops, you require this science, that science, and make sure that everything is working properly, and nothing is optional. If you go to the college, actually some optional subject only, that topic only is optional. Here everything is important. Understood? So, and also you require the form work. पता चल गया फॉर्म वर्क ही गिर गया, आदमी लोग मर गए. People are dying because of the form work failure. Got it? So who is responsible for what? Actually, because it's a temporary structure, water is coming, drainage is happening, form work only gets collapsed. Understood? So safety is also extremely important. So imagine that there are no barricades and all actually, and somebody has fallen down, it's on the spot dead. So you require some temporary arrangement to come down. The people should come down like properly here. They should not jump. Okay, so this is another temporary structure works and all actually. Yeah, this is extremely important photograph. Now, I'll just go a little deep inside. So this is basically the bottom portion of the raft. This is basically the foundation, the strip footing or a strap footing of what? Of the retaining wall. In the retaining wall only, from here the column will be going. For that, this is basically the pedestal. This is also the pedestal, and in between the pedestal there is a beam. This is also pedestal. There is a beam here. There is a beam here. What is this beam is doing? This is basically helping you to transfer the forces taken by the retaining wall. Then what is this? Shoring piles. You require certain safety features. Helmet. You require to give proper shoes. Understood? Many things are there from safety point of view. What is this? Waterproofing. The membrane waterproofing. Okay, now few more things actually I wanted to show you is let's say, what the heck is this? This is the PT strand. These are actually the strand. This is the connector mechanism. This is the plate. This is basically the box, and this is basically the beam. Beam is connected through another, the channel plate. Where it is connected to this, the shoring piles. Got it? So every particular pile, there is a plate given. If the pile is coming quite further, actually we cannot give the plate. It is unfortunate actually some places, but most of the places you will see that the plates are given. Between the two piles only we are giving the PT strands. PT strands are not given just like that anywhere. Understood? PT strands are given only at the particular places. Where it is given? It is given between the two piles. This pile and this pile. This is given in between. This pile and this pile. This is given in between. Understood? So it is like, PT strand with a lot of tensile resistance. So it is given in such a way that if, for example, these piles want to come out, this pile want to come out because of certain heavy load. Imagine on the top there is a truck coming or something which is a surcharge increment, correct? If the surcharge force has increased, that force will be coming on this and this pile will start popping outside. So during that time, the resistance will be offered by these PT strands. Got it? At that place, you cannot go and niche jao zara ye pile ko aage lag lo. You can't do that. This is how even with the very high, full quality, top quality JCB also, this cannot. It will just come down. Understood? Okay, so few more things I wanted to explain you in the next slide. Yes. So here what is this? These are simple actually the compound wall. Why? Because the other people should not come inside and do kya chal raha hai, all this putting the nose inside somebody else's pocket. That should not happen. You should have some kind of protection. And there is some kind of there is some kind of passage is given over here specifically for the people to move. Okay, then there is this is the pile beam. This is shoring piles. This is PT strand, as I told you. There is a specific distance between the PT strand, between this and this. There is some distance, specific distance. You can say that it is the similar distance is given. Understood? Okay, at some place you can see over here actually. Due to failure of certain pile, this is one of the very best example. What is this? The failure of the shoring piles. You have to do some kind of concreting, otherwise water will start coming in. You can say that this area is little wet. Can you see the spot out? This area is also little wet. So this comes under the temporary structural analysis, design and execution. This doesn't come under the permanent execution. Please understand that very well. Come on, say behind me. This is temporary structure. Shoring piles, shoring beams and all, everything is temporary structure. Whereas retaining wall, the permanent structure starts with the retaining wall. Okay, the moment the retaining wall comes here and it will go up to here, that time this guy will be removed. Why? Because the PT strands are going in the neighboring plot. Where the hell they are going? They are going in the neighboring plot. Where is the neighboring plot? This is the neighboring plot. And in India or in many places actually, do you think that this guy will allow, okay, you put this PT strands in my plot, no problem, you are welcome? No. People don't allow that easily. In that case, you need to convince them with the letter or with certain things actually, because we want to protect your building. Otherwise, if your building gets collapsed, we are not responsible. If you say like that, okay, they will give something. But mera building girna nahi chahiye. Like that, something will be happen in negotiations. Project manager has to deal with that. Otherwise, they will say, hey, इतना बड़ा बिल्डिंग बन रहा है, मुझे कितना मिलेगा? All this. So all these things happens actually. Negotiation skills you need to develop in that case. Make sure that you will be having these kind of things. Got it? So this is what the photograph is given for the different projects. Now you can see the type of soil. And do you think that this particular PT strands, the shoring piles, are only up to here. This shoring pile has to go quite deep down. If you leave it only up to here, it will fall down. It has to go deep down, and then that anchor will be below the soil. This is below the soil. How much is the distance? If this is the pile actually, which is going down, generally this distance should be 1/3 of this. Minimum 1/3 to 1/2. If this is, let's say for example, 10 meters. So this one, how much it should be? Between, let's say 3 to 5 meters. Below, this is GL, ground, which ground level? This ground level. Understood? Okay. So this is how actually you need to develop the system. Why two phases? You are having anchor here and you are also having PT strand here. Both the cases, two phases of PT strands. Because it's a cantilever, right? Okay, so I am giving anchor here and I am giving also anchor here, so that it will not come down. So this is how actually the different features actually you need to start learning. This is curing, it has been done. The bottom side, you know that this is basically the reinforcement rebars for the foundations. Strip footing, this is basically the strip footing over here. Pedestal footing for this column, because this is the main column of the tower column. Retaining wall will go only up to the ground level. Why you want retaining wall above the ground? You don't need it. But the column will go even up above the ground. That's why you require such a big depth. But you don't need such a big depth for the retaining wall, because the retaining wall will be only up to the ground, from the basement to the ground. Understood? Got it? So here you can see very clearly the PT strands. See here. How to lay the PT strands and all. Actually, there is a very big science actually. Look at these PT strands. Understood? Yeah. So this is one of the project actually, and believe me, you might have learned quite a lot of things from this live project actually. Yeah. So I think we have taken all the slides. Hopefully, just a minute, let me check. Yeah, we have taken all the slides of the site photographs. So this is the 53-story building actually, okay, in central Mumbai. Right? Now somebody will say, sir, is this the RAT of the same building? No, this is another building designed by us as a company only. This building is in Bandra West, near to the Jarimari temple, if somebody is from Mumbai. Understood? So how this has to be modeled and how the photographs are there. At least that kind of correlation you might have understood till now. Got it? Okay. Now how to give the certain things. Now certain things I need not be teaching you. So let's say this is the RAT 800 raft. So I'll just go to the, let's say, the foundation. So you can see that the raft, it has to be thick shell element. Am I right? Thick shell. Previously it was 800, but later on we have changed it to 750 on the side. I think I've forgotten to just do the text editing here. Minimum grade of concrete, since it is Mumbai, M30 grade of concrete. Understood? So after the M30 grade of concrete is used, then let's say for example how to give the spring constants and all. So you need to go to the point springs. So this is the spring constant. You will have this spring constant, the total capacity of the pile divided by the allowable settlement. And as I told you during last session, this will be generally the 10% of this. And initially you can go for the linear, but later on you need to go for the compression only option. Understood? Why compression only option? Because piles will not work that effectively for the tension. Understood? Let's say for example this is the pile. There is a screen friction and there is a end bearing. Now this is very important. Please look at me carefully. Imagine that this pile is going in the foundation. There is an end bearing. And you are having the screen friction. Let's say this is the ground. Screen friction is there everywhere. And here you are having the end bearing. So whenever there is a compression, this will help. This also will help. But if, for example, this is in tension, this is in tension, this will help, this will not help. Do you agree? If the pile is going down, the bottom surface will say, okay, I am resisting it, but the pile is coming up, bottom portion will say, if you want to go, go hell with you. Do you agree? It's a non-linear analysis. So the spring constants of the pile, when it comes to the compression, is different. But when it comes to the tension, it's totally different. You need to consider you need to deduct the end bearing. So you need to take the component of what is the end bearing, the pile capacity constant I am saying. The capacity constant. What is capacity constant is this. So this is having the P divided by delta, right? So P is having two components. The first component is end bearing and another constant is skin friction. So you need to ask that how much is this and how much is this. Understood? Okay. Operational level 5 minutes to master this. Conceptual level only it takes longer time. Always remember this. This is very tricky and you need to learn in a tricky way only. Understood? Imagine that the bowler is coming with a very high speed but he will put a very lallu ball to you. Correct? So your bat you will go like this and later on the ball will come and it will hit the wicket. That is the bowling. So this is that type of ball. Operational level is extremely simple. Conceptual level is very hard. Understood? So if you are having the compression only option, this is okay. The only moment actually when it goes to the tension, what you will do is in this component you will deduct the end bearing and you will put only the screen friction. And in that context actually you can go for the elastoplastic also. Elastoplastic means you will give the elastic stiffness, compression strength and all these parameters. But generally this is a little bit complex as a matrix. So what we do is we give the compression only and tension only. Different options we'll give and we'll take the results. Got it? Now I would like to tell you, now I'm entering into a little bit more different area. This I have already explained you. Yes. So initially what you will do is actually this exercise I have taken it during the workshop. So please watch the workshop video properly. And the first assignment you will be doing for 100 kilonewton per meter square SBC. What you will do? You will do it for 100 kilonewton per meter square SBC. So this is that SBC. So what I have done it here, I would like to tell you that I have done this as a grouping. What is this? Grouping. Grouping in the sense of how much is the dead load FZ value in terms of the kilonewton. Okay. So first group 532.5, 533. I have taken up to 600. Whatever the figures are there, it is there in the same group. You can see that this is red in color. Why? Because same amount of that shuttering material will be given. I mean same petty, that box. Because otherwise you will have different box here, different box here, different here, different here, different here, different here, different here. Everywhere it is different. The side person will get, तो पगला जाएगा एकदम. Every foundation alag hai sir. That way they will say. You don't do that. Okay. So what you need to do is, you need to make sure that you will be dealing with the different groups. So initially what you need to do, take the dead load plus live load, alright, and if you want to do that in the Excel sheet which we are given, you need to add some 5 to 10 percentage of the extra load, because the foundation sulfate will not be there. Understood? So what you will do is you will add the 10%, 1.1 times the dead load live load. But if you are directly doing it in SAFE, you don't need to add it. Okay, so you will be doing grouping, because this I am identifying that it will be a separate group, and here also this is in the range of 1000 to 1100, that group. Somebody will say, sir, this is 800. You can create one more group, but I don't think there is a necessity to do that. If you want to do many groups, actually economy will be there, but site execution will be the problem. Understood? So try to create 5 to 6 groups. Don't create too many number of groups. Understood? That way. Alright. So after this, once this is over, actually, then you will go to the next one. This is 100 SBC. Once you have done this, then you can go to the next one, which is 200 SBC. And then you can go for the 300 SBC. 300, 200 and 100 SBC is what actually you guys need to do that. In 100, 200 and 300, grouping, will it change? No. Why? Because you will be importing the file from the ETABS to SAFE. So the load is there in the ETABS only. In SAFE you are just modeling it for the either it is a isolated footing, combined footing or raft footing. So you will be doing only the segregation of different types of foundation systems. Understood? So that way only you will be doing it here. So 100, 200 and 300 SBC. Okay, so depending upon that you will be doing this. So 300 SBC. So foundation thickness will change. Now, while modeling this, I wanted to just tell you a few things. That this one you can give this as a stiff material, or you can give that as a column. This one is, it will come it as a drop panel. But the drop panel you need to give this as a full depth from here to here. Please don't give only up to here to here. You need to give full depth from here to here. And you need to mention that as a drop panel. Many people, they forget that, they give that as a slab. Don't do that. You need to give that as a drop panel. It will be thickened slab. Understood? And this would be given it as a foundation pad, which is also thick shell or thick plate. Got it? So once this is done, then, and generally what happens is the dimension need to be done in such a way that it is always the 45-degree angle. This angle is always the 45-degree angle for the load transmission. Okay, so it means when the 45-degree angle, this is equilateral triangle. Do you agree? Equilateral means whatever this dimension, the same thing is this one. So whatever is the depth, the width also will become same only. It means this is 90 degree, not, sorry, I used the wrong word. No, it's not equilateral, 45-degree angle will come. So whatever is the dimension of horizontal, it is the same dimension of vertical dimensions. 45, 45, 90. Like that 180. Yes. So this is basically used for the punching. There are certain type of reinforcement which is punching governing, shear governing reinforcement, that is point number 1, and there are certain reinforcement which is bending governing reinforcement. Sometimes it is punching plus bending, but many a times it is not the combination. Many times it is either punching only or bending only. So if it is punching governing reinforcement, 100% this is 45 degree. But if it is not punching governing reinforcement, this need not be 50%. What is 50%? Whatever is this depth, this is 50% of this. Why? Because this is 45 degree. But if it is bending governing reinforcement, it will not be like that. What does that mean? Just now I shown you one raft. where the thickness is 750, correct? But the drop panel was 2 meter. If it is 750, this should have been how much? 1500. Correct? Where it is I have shown you? Over here. What is this? 800. But you know that this is 750 if you go to the define and all. So how much is this? 2 meter. Can you go for 1500? But I was getting too much of heavy, very heavy reinforcement I was getting. Where? Here. Like this. Like this. Very, very heavy reinforcement. So to reduce the diameter of this rebar on the spacing, adjustment of the spacing, I have to increase the depth, because mu upon bd square, the moment I have increased the depth, the moment of resistance also will be increased substantially. Understood? Okay, so this is how it is. Now, when it comes to the degree of restraint or constraints, actually, how it is? There are basically fixed, hinge, roller, and there are springs, which is area spring, line spring, or point springs. So, whenever it is a fixed, how many degrees of freedom will be there? 0. Degree of freedom will be 0. Degree of restraint will be everything. All 6. Understood? So, Fx readings you will get, Fy reading you will get, Fz, Ry, Rx, Ry, Rz. All the readings you will get if you are having the fixed. These are types of supports I am telling you. When it comes to the hinge, you will get only the Fx, Fy, Fz. You will not get the Rx, Ry, Rz. Why? Because the first one is the fixed support, second one is the hinge support. In the hinge support, the rotation is allowed. That's why this one will be duck, 0. Do you agree? Now, when it comes to the roller support, this is basically the roller. Now, roller means, is it in one direction or in two direction? Now, this chair is actually going in this direction also, it is going back side and front side also. But railway line, it is going in one direction, it cannot go other direction. If you go to the other direction, problem will happen. So that roller is only in one direction. Do you agree? Yes? Yeah? So roller is there only in one direction. Sometimes. But sometimes it is in other direction. That's why this is a question mark I have given. Okay, I have given the question mark. Why? Because it depends upon the requirement. And this is also question mark, because this is also based on the requirement. But one thing is fixed, vertically it is not allowed. And sometimes if you see the railway lines, actually vertically also there is a spring. Correct? No? Shock absorbers are there. For the railway, the wheels, the shock absorbers are there. You might have seen that sometimes. Got it? So these are the different types of supports for the points. Even like there is a point spring, line spring and area spring. Just now only I have shown you. Now there is no particular character. In all the cases it will change. Everywhere there is a big question mark. Why? Because it is Rx, Ry, Rz, Mx, or maybe Fx, Fy, Fz. Everywhere it is required. Based on the requirement you will give the figures or the values. Or you can change the values. How come it is like this? I'll show you. This is it. You take ETABS, you take SAFE, you take SAP, you take NODAS, you take SAP, or maybe any software. So if you go to, let's say, the supports, let's say for example I want to give these points at some kind of support. So what I'll go is I'll go to actually I have run the analysis. Okay, I'll remove it now. If you go here, there is a point restraint. So can you give this? If you give this fixed, actually everything will be fixed. Yes? Yeah. You can, if you see this rotation will be 0, means it is allowed to rotate. This is roller, means only FZ, other things this is roller in only in one direction, where it is allowed in X direction. X where it is this way. This is like railway line going in this direction. This is in Y direction, so it is allowed to go in the Y direction. So these are the point springs. Now similarly, if you go here, these are point restraint. Now there is a point spring. Now this is something else. What is this? Everywhere you can give the value as whatever you want to give. What is this value? Force upon settlement. Understood? What is this value? Force upon settlement. And what is this value? Moment divided by radians. What is moment divided by radians? Let's say, you might have seen that truck drivers removing the truck tire. Imagine that. I'm a truck driver removing a truck tire. So this is a tire. And these are, let's say, 4 screws. There are generally more than that. I want to remove this. Initially it will be like this because it is too tight. Correct? It is too tight. Whatever amount of moment I'm not giving force. I'm giving the moment. I have to generate the moment. I cannot I cannot do that. I have to apply at a distance so that I can generate the bending moment. Do you agree? So that is the moment divided by the radian of displacement. Initially it will be 0 displacement. Imagine that I am doing like this to the spanner. It will go down. No, I have to maybe stand or jump on that. Correct? Yes. So to generate this heavy bending moment so that some kind of radiance, the displacement will occur. Similarly, it is reverse case here. You don't want everything to get rotated. It is anti like this. So how much amount of bending moment is coming and how much amount of the rotation is allowed. That is the moment divided by radians. Understood? Okay, so it is a rotational stiffness. What is it called as? Rotational stiffness. It is a spring stiffness. So this is translational stiffness. This is rotational stiffness. But I still remember in the college days, कैसा गंदा पढ़ाया था बाप रे. इक्वेशन देख के थीटा डेल्टा अल्फा बीटा ऐसे लिख के then it is down, then again it is down, then again it is down. Oh paiyo. Okay, so very complex formulation with the software technology make it very simple. Understood? That is your primary job. Too much of complexity is already involved. Okay, with the software technology, try to make it so subtle and thinner and lighter so that it is easy to feed it inside. Got it? Right? So these are basically the different systems. That's what we have seen it over here. Okay. Alright guys, so thank you very much and see you tomorrow. Bye bye.